Welcome to another, wrong video, draft physics video presentation. Yeah, pretty much. Subject might be open. Let's see where I go. So I'll start with one comment. Regarding heat, shouldn't black holes be extremely hot? I don't know. The whole idea of a black hole, all right, is dependent on a whole theory that I think is suspect. That is that gravity, this property that matter has, that somehow you can make an infinite amount of it in an infinitely small amount of space, that it's some sort of resource, this pressure, that is, you can collect as much as you want of it. And I would argue that no, there's a limited amount of pressure, and therefore there's a limited amount of ability to get matter really close together, so that you can have very dense objects like maybe neutron stars have some kind of viability as a theory, because the neutron would be an electron and a proton fairly small, close together. And you could imagine that those dipoles could be arranged closely together in matter by having the electrons and protons oppositely arranged, and you could take a lot of matter and put it in a small amount of space, and therefore make some sort of argument that each bit of matter has a certain capacity to create pressure. But I would argue that the amount of pressure is limited to the amount of pressure the atoms can create by being in association with each other, that there's not an infinite amount at any rate, and that it has to be made of something, and there's no such thing as a singularity, and there's no such thing as light not escaping and all of that stuff. And so I would argue that heat is a specific kind of expression of the fact that there's energy in a system. We'll just say that much for now. Given their enormous gravitational field, is there a way to estimate their temperature? So again, the temperature doesn't... You could have gravity without temperature if the matter that you're making the gravity out of is not conducive to random movements. If it's tunneling, if the energy is allowed to travel through it in a straight geometry without being dispersed. Heat is kind of a expression of the fact that the energy is seeking, getting out, and is moving in different paths. And if you could move energy straight, like in a superconductor, there's no heat, less heat, not a substantial amount of heat. So it's really about the efficient movement of momentum. So if momentum has a road to travel, it travels the road. If it disperses, that's heat. Something like that. All right, so get some chalk. Let's see where we go. See where we go. See how and where we go. See how and where we go. All right, so something I have attempted to propose as a theory of heat, in terms of what we see of heat, that is the infrared radiation, just has to do with what the nature of a surface is. And the idea in the simplest experiment is the black body kind of experiment. So you heat an object, like a piece of metal, by pumping energy into it, different frequencies, so to speak. And the idea is that it's not really radiating the heat. It's just having the bits move. The bits will move in this direction, and bits of it will move in this direction, and bits will move in this direction, and bits will be moving in this direction. So it's vibrating. And the trick is that when anything's got movement in all these different directions, the key thing is if you can get an electron to be hit by a force and moved, and the electron hits another electron doing exactly the opposite thing, that in some sense you're canceling or balancing the imbalance. So that would be taking heat out of a system, would be when two opposite forces interact while they're trapped inside of matter, that you'll just neutralize whatever is there. So it'd be like destructive interference, but it's not really destructive, it's just restoring a balance. And what all objects do is that. So the stuff that ends up hitting something else, you could argue the two motions in two opposite directions that meet essentially cancel the motion, and the only motion that survives in the end is any motion that doesn't have a motion that's going to interact with it. So this sort of happens in gravity. You can make the argument that in gravity, if you create objects moving in two different directions in an orbit, what'll happen is they'll bang into each other. So if I had a bunch of little marbles and I threw them this way, and I had a bunch of marbles and I threw them this way, there'll be a slight difference. One of them will have more total momentum, and after they, I have them going the same way. Minor error. Alright, so the the ones going one way, well, over time they'll bang into each other, they'll balance, and whatever's left over, whatever didn't stop moving, will be the thing left. And that will be the only direction stuff will be moving, is that remaining direction, is sort of the idea. So it's not really destructive and constructive. It's either you're adding energy that doesn't get balanced, or you add energy that does get balanced, is really what it comes down to. So there's movement that just happens not to hit something going the opposite way, and all of that gets to stay, and so then you end up with something that ends up with a balanced system where things all become resonant. Anything out of the resonance, that is, anything moving out of the sequence, that is, everything's going this way and then hits the wall, and then stuff bounces this way. And so as long as they all do that collectively in a group, they won't end up banging into each other. So the groups that are, don't have a constituent group going the opposite way won't have interactions, and therefore will be preserved as heat. So anyway, the point would be is when you pump energy in, you're pumping frequencies in almost to a flute, and when you do that, there's certain resonance kinds of energy that'll end up being dominant because they don't balance out, because they're all those pieces are going in one direction and there's no counter pieces going the opposite way, and they'll just bounce back and forth inside the material, so to speak. And the bouncing back and forth basically means that there's going to be on the surfaces, there's a proton and an electron. And probably more specifically, there's an electron and another electron connected to another atom. And so these two atoms are repulsive. And what's going to happen is this electron will be pushed. That'll compress the force between these two and create movement in this electron out. And as it moves out, it's basically now going to interact with the real world that's constantly bringing force in. So the real world has this energy always coming in. And you could sort of imagine that as this force compresses, then there's more interactions between here and here. So this electron is moved, that puts pressure here, multiplied, and this electron moves. Now as it moves, what's it doing? Well, it's changing its distance to the real world. So it's essentially expanding the surface. And as it's doing that, it's kind of doing it in an interesting way, in the sense that a bit of the external universe could hit it at this one moment when it's here. And now it moves to here, and then it hits another piece of the universe at that location. Well, the fact is the reflection from this will end up being in the same location this reflection is going to end up being in the same, it'll be at this location when this one reflects. And then the next one, is that still on the board? Yes. Okay, so and then the next position, the same thing is going to happen when these two now are going to be both at that position, and then they're going to be both at this position when this piece could reflect. And you'd end up with the three pieces of energy all leaving at the same time. And then that cycle of pushing the electron out at a speed fast enough to hit the external universe, and the external universe ends up sending back a signal that's in alignment, and it'll have, as that continues to happen, the electron goes out and it's pushed back in, it goes out and it's pushed back in, it's pushed back in by each one of these events, it's pushed back in again, and then it's the heat does the same thing, hits that electron again, and that's what ends up creating your frequency, where you're producing the reflections at the right frequency. So the hotter you make something, the more you're pushing, the faster you end up pushing on these electrons. The faster you push on this electron, the faster this one moves, and the faster your frequency becomes, the tighter the frequency becomes that you emit. So the hotter you make it, the surface is what's really, the surface is going from here to here. If you just want to call this electron the surface, the outermost electron is the surface. That surface keeps moving in and out, and as it moves in and out, it's creating reflections to the rest of the world at those positions, and that's creating the photons that you see. So the photons aren't actual energy leaving. They're just a reflection off the surface that's being moved by the energy inside the material. So the energy in here pushes electrons out, and the force pushes them back in, and those reflections end up being at a time cycle based on how much heat is in the substance, which changes the speed that the electron moves at, which changes the frequency that the external world reflects off that surface. So the photons that something that's hot is emitting aren't photons coming out of the substance. They're just gravity, essentially, reflecting off the surface and reflecting at a timed interval of, reflection, 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 reflection at the right sequence. So if that's true, then everything else has to be sort of rethought in terms of the fact that the energy isn't getting lost to the external world. It's just the movement is all you need to have, is the movement into some other medium, and the other medium isn't ether, but it is this external pressure, the cosmic background radiation. You could think of it coming in without a frequency, and the fact is that the surface moving creates the frequency that we could maybe see it at. Our new frequency is imposed on it by its movement. And the only way the hot object gets cold is just through the process of eventually having the balancing interaction, where the things are bouncing around and they eventually do hit something moving in the opposite direction. But until that happens, it stays hot. And if the oscillation is all consistent, then the heat will stay until something from the external world pushes on it with a counter frequency that interrupts the bounce rate by creating some irregularity that will consume the energy by hitting stuff while it's on the way out, it hits it more on the way in. Yeah, so it's always losing it to the environment, because the environment is creating oscillation that's not, it's creating all kinds of frequencies. And now and then the frequency is the same as the frequency that was preserved inside the material. And whenever it meets that frequency perfectly in a spot, then it becomes balanced at that spot again. And there's no more energy. Something like that. Alright. Take a break. Or something like that. This one and this. Alright, back. Tired. Sorry. Yeah. Not much enthusiasm. Alright, so the other circumstance is the light coming into a surface and reflecting. And I guess I would argue that that's sort of a kind of a simple thing to understand. There could be a simple mechanism. The simple mechanism is basically you are pushing electrons into pressure. So there's electrons on the surface. You're going to hit one of these electrons. You could hit one back here, of course. They're going to be staggered in normal matter. And the idea is if you hit an electron with a force at an angle, that the electron's moving into pressure, so that it's going to end up going into the pressure and then being pushed out of the pressure. And that would be the angle of reflection. It would be the fact that you're pushing at an angle into a pressure. It pushes back. You still have this motion. You know, the component of this way is in, and so you keep moving this way as you have the reflection coming out. So you have the energy going this way into the surface, and it just retains the two portions of that momentum. That momentum has a vector parallel to the surface, and has a component perpendicular to the surface. And that's why you end up with this bisection, is because both of those momentums are, in a sense, real, in terms of the fact that you're just moving into pressure. You're moving into a system that's going to say these other electrons, as you get closer to them, are going to push back, and that pushback is going to end up getting you out of the pressure, and the pressure gets stronger as you go deeper. And so the way you're making the photon is just because the electrons are going to move. And when they move, they're changing their position to the world again. So when some new piece of energy hits the electron back here, it doesn't reflect. It reflects at a position where, you know, the surface was here, and you've moved the surface to here. So instead of reflecting here, it's reflecting off something back here. And then you're going to move, that electron's going to be pushed by the pressure. It's going to move to a new location, and then you're going to hit another piece of energy there, and those two arrows will line up. And if that's happening in more than one place, you'll end up with you know, a method of creating photons. So as the energy comes in with a frequency, it'll end up coming out with a frequency. And depending on you know, the fact that you could heat the material and end up making the surface vibrate at a specific frequency, dependent on how strong these atoms are, how much pressure they can produce. And as you do that, then the surface ends up vibrating at that frequency, and that's why you get certain places where you get a strong, you know, you get bands of light, you know, where it's giving you a lot of photons in these exact frequencies, because the pushback frequency is an exact amount of pressure. So when the electron's moving back out, it moves back out with a consistent pressure, because it can only produce the pressure based on what's in the substance. So what stuff is moving around inside the substance is going to dictate the pressure of the substance. Something like that. Yeah, so maybe I just keep it short, simple, a little bit on heat. So I'm basically saying that heat isn't overtly radiation of energy. It's expanding and contracting a substance. So it's moving the electrons, and the electrons being in a different position means, like a mirror, they reflect the world from different places. And by reflecting the world from a different place, you make the reflection go on and off. You put a signal on the reflection. Yeah. Okay. And the energy's used up by moving the matter bits, the electrons and protons moving, is what consumes the energy over time. Consumes is the wrong word. Again, it just balances. The system is either out of balance or imbalance. So zero energy is just balance. There's as much going this way as there is that way. And everything else is a consequence of there being pieces that have no balancing doppelganger duplicate, no opposite force. Yeah, in the near term anyway. I mean, eventually every system would leak all its energy and everything would be balanced. But for periods of time, they can remain a lot of imbalance. Yeah, probably good enough. Alright, we'll call it a video. Yeah, sorry. Shouldn't make videos when I'm just not in the mood for some reason. But anyway. Did I even turn this back on? I don't know. Must have. Alright, till next time.